Hi kids, today we'll see about the comparison between the gravitational force and Coulomb's force. We are not seeing only the difference, we are just comparing what is gravitational force and what is Coulomb's force. And we very well know that the gravitational force is measured between the two masses and the Coulomb's force is measured between the two charges. Here mass, here charge. And the first point, both are inversely proportional to the square of the distance between the two masses, and here inversely proportional to the square of the distance between the two charges. So when we take two masses, what happens? In the gravitational force, what we see is two mass, and between the two mass m1 and m2, here if I am taking m1 and m2, the distance between both is taken as r. But in case of Coulomb's force, Q1 and Q2, and between the Q1 and Q2 the distance is taken as R. So both are, that is gravitational force is also is proportional to the square of the distance between the two masses, and here too the Fe, the electrostatic force, is also inversely proportional to the square of the distance between the two charges. Between two masses the distance are, between the two charges also the distances are. This is Fg, which is nothing but the gravitational force, and here Fe, which is nothing but the electrostatic force. The second point, always this gravitational force is attractive force, but here it may be attractive or repulsive depending on the nature of the charge. Because mass, it is not measured in terms of positive or negative, but charge is always measured in terms of positive or negative. It holds the polarity, and here nothing like the term called polarity. So positive charge, like charges, we know very well, like charges always repels, and opposite charges, means unlike charges, always attracts. So here it may be attractive or a repulsive force. If they are asking you, just compare both the things, which is gravitational force and Coulomb's force. You can first write the statement, then go for these points one by one. And here the gravitational constant G value is 6.67 into 10 to the power minus 11 Newton meter square Coulomb to the power minus 2. And keep on telling you, don't forget the SI unit. And this G is lesser than the K, which is nothing but the gravitational constant, because here it is given like minus 11. But see the K value. In Coulomb's law also we saw what is the value of K. K is nothing but a proportionality constant. K is equivalent to 9 into 10 to the power 9 Newton meter square Coulomb to the power minus 2. Easy to remember. Newton meter square, as it is between the mass, kg to the power minus 2. As it is between the charge, Coulomb to the power minus 2. Here the value is 6.67 into 10 to the power minus 11, and here it is 9 into 10 to the power plus 9. What is this? This is plus 9. So which is greater? K is greater. K is always positive and it is greater value comparing to the G. This is your third point. The first point is inversely proportional. Second point is whether it is attractive or repulsive. And third one is G value. Fourth one, the gravitational force between the two masses is independent of the medium. Very, very important. What is the value of F? F is equivalent to G into M1, M2 divided by R square, and G is a proportionality constant. Nowhere we are relating with the medium where we kept the two mass. Two masses where we are keeping, we are not at all bothered. Wherever it is, the gravitational force exists between the two masses. But here this is not it is not the case. The electrostatic force between the two charges depends on the nature of the medium where it exists. The charge where it exists depends on the medium. The force will vary in which the two charges are kept at rest. Where we are keeping the charges, in which medium, either it may be air or vacuum or water or kerosene, wherever it is, it depends on the medium. Which one depends on the medium? Electrostatic force, but the gravitational force never depends on the medium. Thank you.